As we've talked about, you know that in every function type, we have a parent function. So just like in any family, you have a parent, something that that it comes from. So in a function family, you have a parent function that all other functions like that come from. So here on these examples that you see, these are the parent. This is the parent function, which is y equals x squared for a quadratic. This is what the original quadratic equation looks like, and then we transform based on that. Okay, there are transformations made. We slide it to the left, we slide it to the right, up, down. We flip something over an axis or something else. Okay, so there's several different things that we can do, and so that's what we're going to talk about in this video. Of course, the simplistic quadratic equation, we call it the parent function, is y equals x squared. Okay. Again, we call it the parent function, so that's all of that information just repeated. And a transformation is a change either to the size or to the position, the location of a figure. Okay, and so what we're going to do is we're actually just going to graph these, and then we're going to describe how it compares to that parent function. So in order to graph them, we've got to do a little bit of work here. So again, our vertex point is going to be hk. So our h value here is going to be a -2, and our k is going to be a 0. So that is going to be here in this middle spot, so -2 and 0. And then we're actually going to use our calculators to help us out on this just because it's a little bit faster. And so we're going to plug this value in. Okay, we're going to do, let's see, a positive x plus 2 squared. And then we're going to get rid of anything out there, and we're going to make our table. Okay, so second table. There we go. And we have -4, 4, -3, 1, -2, 0, -1, 1, and 0, 4. So again, just filling in those blanks just like we did before with the information that's on our table. And then we're just going to graph that. So we're going to go -4, 1, 2, 3, 4, up 4. And then we're going to go to -3, 1, 2, 3, 1. We're going to go to -2, 0, -1, 1, and 0, 4. And we're going to draw this graph. Okay, and if you look, at the only transformation that has happened is that our vertex has moved from 0, 0 to -2, 0. So transformation, it has moved left 2. Okay, that's what has happened to this. Okay. And we're going to do another example here. We're going to look at this one, next one here, x squared plus 5, and I'm going to plug that into the calculator as well. We're going to do x squared plus 5. We're going to do second table, and here's what we have. And we're actually looking for a vertex. We can do that here. We don't even have to find it using h and k, but we could. So h is going to be 0 in this case, and k is 5. So 0, 5 is our point that's going to be in the middle. And then we're going to go up from there. So -1, 6. I know it's hard for you to read my calculator, but I'll fill those in for us. And then -2, 9, 1, 6, and 2, 9. Okay, so we're going to go ahead and plug those in onto our graph. So 0, 5, -1, 6, 1, 6, -2, 9, which is going to be actually off of our graph. It'll be up here somewhere, and 2 will also be off of our graph. But we still have 3 points, and we know that we can go ahead and graph that. Okay, so the transformation here appears to be the fact that it is moved up 5 places. Okay, so it has been moved up 5, or has translated up 5. Okay, so that's basically what we're looking for here. So what you notice is that this value right here, that h, is that left to right movement. Okay, 2, it moved 2. and this K value, that 5, is our up and down movement. Okay, so remember H moves left to right, so H is our left to right, and K is our up and down movement. So just a reminder, just something that you may see, and it may just be helpful. We're not going to spend a lot of time on this, but I just wanted you to be aware of it and have an option to see it. And then we'll talk a little bit more here, specifics about it, in just a second.